Okay, hi everybody. This is the Math 31 applications review. This is question 13. It says a block of ice has a square top. Okie dokie, let's just take a quick look at this. So square top and rectangular sides. Okay, so we're not entirely sure. I mean, that's a really weird looking ice cube, if you will, but whatever. We know that the sides here will be x and then the height will be y because it's a square top and rectangular sides. At a certain point in time, each dimension of the square is 30. Okay, so we're telling you that the x is 30 and decreasing at a rate of 2 centimeters per hour. Okay, so dx by dt is negative 2 centimeters per hour. Okay, while the depth, which is in this case that's the y variable, is 20 centimeters and is decreasing at a rate of 3 centimeters per hour. And again, I put negative there to indicate that that's decreasing. The question is, how fast is the ice melting? Okay, now that sounds to me like a volume question. We're looking for the rate at which the volume is going away as a function of time. That's what I don't know. So what I need to do here is create a relationship between these three variable portion pieces in this problem. The variables will here be the variables being volume and then the dimensions of the square and the depth. Well, that's pretty straightforward though, because that's going to be length times width times height. So volume is equal to x squared y. Now, I have information about how each of these changes with respect to time. So I'm not bothered in this case by the fact that I have two variables on the right-hand side. What I'm going to do is I'm just going to take the derivative implicitly with respect to time, and I was going to do that anyway because this is a related rates problem. But now I'm seeing how this is related to how we did implicit derivatives back in the derivatives chapter. So this will be dv by dt. Okay, the derivative of v is 1 times this. Now this requires the product rule. Okay, so the derivative of x squared will be 2x dx by dt times y plus x squared times the derivative of the y. Well, the derivative of y will be 1 times the derivative of y, dy by dt. And now I'm just going to plug in the pertinent information because I've taken the derivative. Now I can plug in the specific numbers. I couldn't plug in the 30 and the 20 first, because if you plug those in, you're going to get a number for volume and then the derivative will just be 0. Okay, so if you plug those numbers in too soon, this whole process really collapses. So now this is going to be 2 times 30, okay, times negative 2 times 20 plus 30 squared times negative 3. Okay, and so now I just want to make sure I get this all correct. So 2 times 30 times negative 2 times 20 plus 30 squared times negative 3. And the answer is, this looks like negative 5,100 centimeters cubed per minute. Okay, this is a pretty, oh, sorry, not per minute. Sorry, I was going to say it's a pretty big number. That's an extremely big number if it's per minute. This is per hour though. Okay, and so there you go. And actually, if you think about the units here, that makes perfect sense because this is going to produce a centimeter squared times centimeters per minute. Yeah, that all makes sense. Everything's pretty consistent.